Okay, so 5.3 is our next section within Unit 5. Okay, so up here I just reminded you exponential form y is equal to b to the x, and then your log form is log base b y is equal to x. So again, like the b is in the basement, it's the base, and then your exponent, it's equal to the exponent. All right, so this lesson is just about finding the inverse. So it is another way of putting things from either exponential to log or log to exponential, but there's just more steps than there were yesterday. So yesterday was just kind of leading into this. So example 1 says, find the inverse of y equals log base 5x. So this is my log function, okay? Your step 1 is to switch x and y. So originally the y was on the left, the x is on the right. I'm going to switch it. So now this says x equals log base 5y. My step 2 is going to be getting that log base by alone if needed. In our case, this y is by itself, so there's nothing like being added or subtracted over here on the end, okay? So I don't like this step for this particular log, we don't have to do, but I wanted to put it in there because there will be ones that you have to. So in this case, because it's just log base 5y, I'm able to go directly to step 3 where it says to put my log form to exponential. So remember, this equals x represents your exponent, and then the basement number is your base. So I've got my base of 5 because that came from the basement, and then my exponent is the equals the exponent, so it's x, and then the other item is just the equal y. So 5 to the x equals y. My last step would be to get y alone if needed. But this y is by itself. There's nothing being added or subtracted to it, so I'm good. So this is my final answer. 5 to the x is equal to y. So the inverse of y equals log base 5x is 5 to the x equal to y. Final answer. So you're going to write in whatever steps help you right here. Then you're trying got it 1, find the inverse of y equals log base 12x. Same steps as up here. All right, example 2. Find the inverse of y equals log base 2 x plus 5 minus 4. Okay, so this is longer compared to what we've seen above. Above, there was only one thing inside the parentheses, and there was nothing added or subtracted on the end, so there's going to be more steps. So my first step is still the same. I'm going to switch my x and y. So right here, I switched it. It was originally a y on the left, now it's x on the left. It was originally the x with the 5 in the parentheses, now it's the y. So I have x equals log base 2 y plus 5 minus 4. My second step, get the log base by alone if needed. Okay, it's not alone, right? This log base by, this right here, has a minus 4. Okay, so that's not alone. So I need to get this 4 away. So I do the opposite of minus 4, and I'm going to add 4 to both sides. These 4s are going to cancel out. And then x plus 4, I just write it as x plus 4. Because I can't combine them together and make it one term, I leave them separate. So x plus 4 equals log base 2 y plus 5. So this whole log came right down. Okay, now that my log base y is alone, okay, and this is considered alone because it's in parentheses, so this is okay. It says, and I'm going to put my log form to exponential. So if you remember the equals exponent, so this is the exponent, this whole thing, x plus 4, and then my base is in that basement of 2. So my base of 2, that's where it came from. My exponent of x plus 4, it came from this side of the equal sign. And then this y plus 5 that is not the exponent, is not the base, goes on the other side. So 2 to the x plus 4 equals y plus 5. Okay, and then the last step, get y alone if needed. So right here, I see 2 to the x plus 4 equals y plus 5. This plus 5 means my y is not alone, so I've got to get rid of it. So I'm going to do the opposite and subtract it from both sides. This plus 5 minus 5 cancels out. I'm just left with the y over here on the right. And again, this has an exponent of x plus 4, and this minus 5 does not, so I'm just going to rewrite it separate. So 2 to the x plus 4 minus 5 equals y. Final answer. So you'll try the got it problem after you write in some steps right here. Find the inverse of y equals log base 4, x plus 2 plus 7. So again, same steps, different numbers. Okay, example 3. Now I'm going to find the inverse of this exponential, y equals 8 to the x. So I start with y equals 8 to the x. I have the same step 1. I'm going to switch my x and y. So I switch my x and y, and it becomes x equals 8y. My step 2, get the base with the exponent alone if needed. So this is my base and exponent, my base of 8, my exponent of y. It is alone, so this step I get to skip for this problem because there's nothing being added or subtracted over here on the end. So I've got x equals 8 to the y. Because now my base is alone, I can go from exponential form to log form. So if you remember, the b, my base right here, that's going to go in my basement of the log, so log 8. And then the y is the equals exponent. So I've got my equals exponent of y over here. This x that was over here is now comes down in my blank spot. So log base 8x is equal to y. Once I'm at this point, my last step is always to get y alone if needed. My y is over here all by itself on the right-hand side. There's nothing being added or subtracted to it, so that's my final answer. So the inverse of y equals 8 to the x is log base 8x equals y. Final. So again, we write some stuff down up here, something that's going to help you, and then find the inverse of y equals 15 to the x. All right, last one. Find the inverse of y equals 4 raised to the x minus 3 plus 6. So again, this is longer than what our exponential in example 3 was. So I have this exponential. Y equals 4 raised to the x minus 3 plus 6. I'm going to switch my y and my x. So my x, so now I have x equals 4, y minus 3 plus 6. Step 2, get your base with the exponent alone if needed. So this 4 is my base, the y minus 3 is my exponent. This term right here is not alone because I have a plus 6 here. So I need to get rid of this plus 6. So I'm going to subtract, because that's the opposite of plus, on both sides. So minus 6, minus 6. These 6's cancel out. Again, these are not the same type of term, so I can't combine it to 1. I keep it separate. X minus 6 equals 4 raised to the y minus 3. Now that I have my base, now that I have my base and exponent alone, I can put it into log form. So if you remember, the 4 is the base, so it's going to go in the basement, so log 4. The x minus 6 is not like one of my special phrases, so it goes directly after the log 4, so x minus 6. And then the exponent is equals exponent, so y minus 3 goes on this other side of the equal sign. So log base 4, x minus 6 is equal to y minus 3. And then my last step, get y alone if needed. So again, I have log base 4, x minus 6 equals y minus 3. This minus 3 is on the same side as my y. I need y alone, so I've got to do the opposite. So this is a minus 3, so I'm going to add 3 to both sides. Negative 3 plus 3 cancels out, so I just have the y over here now left on the right-hand side. And then this log term and this constant number are different types of terms, so I have to leave them separate. Log base 4, x minus 6 plus 3. Make sure you're remembering to put the parentheses around this stuff after the log base. So again, writing in something up here, and then you're going to try finding the inverse of y equals 6 raised to the x plus 5 minus 2. And then the answers to your got it problems are taped around the room for you to now double check your got it 1, got it 2, got it 3, and got it 4.